Good day, Rowishans. Today, I'll be teaching you another lesson. But before that, let's pray first. Before we start with our lesson, I want you to get yourself ready and have your learning packet with you. You will also need pen, paper, scientific calculator, or the app that is present in your cell phone. Now that you are ready, let's start with our lesson. For vectors that are not forming right triangles, we cannot just use the first method that I have taught you. Instead, we will have to get first their components using this formula. For horizontal component x, we will use f of x is equal to f cos theta. And for vertical component, we will use the formula f of y is equal to f sine theta. And after finding the components of the vectors, we will now use the Pythagorean theorem to find its magnitude and the tangent function to find the direction of the resultant vector. Now, to solve for the resultant vector using component methods, there are 5 PE6 steps because P6 is just easy. We have first, number 1, determine the vertical and horizontal components of the given vectors. As I have told you, we have the two formulas. For vertical component, we have f sine theta, and for horizontal component, we have f cos theta. And then number 2, add all x components and represent it as summation of f of x. Number 3, we will also add the vertical components and label it as summation of f of y. Fourth, use the Pythagorean theorem to find the magnitude of the resultant vector. And fifth, use the tangent function to find the direction of the resultant vector. Is that easy? Let's try with an example. A car is headed east with a force of 100 newtons and then turns 30 degrees with a force of 150 newtons. How far is the car from its initial position and what is the direction of its displacement? We have these two givens. F of 1 or force number 1 is equal to 100 newtons is. Okay, and it is indicated here that is also equivalent to 0 degrees because we need to find the exact value of that direction where east is always equal to 0 degrees and then n or north is equal to 90 degrees and then west is equal to 180 degrees and then south is equal to 270 degrees. Now for east, we will use 0 degrees. And then f of 2, we have 150 newtons, 30 degrees. So first, we will find the vertical and the horizontal components of these two vectors. Okay? So we will find the summation of f of x or the horizontal components of this given vector using the following formula. F of 1 or f of 1x is equal to f of 1 cos theta. Since it is horizontal, we will use the cosine value. And then, we will substitute the given values. F of 1 is 100 newton cos 0 degrees. Okay? So that is the given direction or the theta. And then, we will use the same formula to find the second horizontal component, which is f of 2x is equal to f of 2 cos theta. Okay? So substituting the given values, we have 150 cos 30 degrees. Okay? So getting that value, we can now solve for the f of 1x and f of 2x, which are the horizontal components of the vector. Okay, using calculator, we will have first 100 cos theta. You will just type 100, okay, and then cos key, and then 0. You will get the value of 100. Okay? So that is the first horizontal component of or f of 1x. Okay? Next, we will get the next 150 cos 30. You will get 129.90, or that is the second component of the horizontal component of the vectors. Okay, so we will write down here, we have 100 for f of 1x, and f of 2x we have 129.90. And then to get the summation of f of x, we will just add the two values. We have 100 plus 129.90 is equal to 329.90, and that is our horizontal component or summation of f of x. Is that easy? Did you follow? Now, using the same given, f of 1 is equal to 100 newtons east or 0 degrees, and f of 2 is equal to 150 newtons 30 degrees, we will now find the vertical component using the sine function. Okay, so we have summation of f of y, or the vertical component. So we will have f of 1y, since it's vertical, is equal to f of 1 sine theta. Okay, so we will use now the sine function, and f of 2y is equal to f2 sine theta. Okay, we will substitute again the given values. We have f of 1 is equal to 100 newtons sine 0 degrees. Okay, and then we have 150 newtons sine 30 degrees. And then we will use calculator to calculate the two values again. So we have here, okay, our calculator, type 100 sine 0 degrees, and that will give you a 0. Okay, and then we have 150 sine 30 is equal to 75. Okay, so going back to our board again, f of 1y is equal to 0, and f of 2y is equal to 75. Now to get the summation of f of y, or the vertical components, we have 0 plus 75 is equal to 75, and that is our vertical component or summation of f of y. Did you get it? Now we have our new given values for horizontal and vertical components. We have summation of f of x is equal to 329.90 newtons, and for summation of f of y, we have 75 newtons. Okay, so now we will use the Pythagorean theorem to calculate the magnitude r of the resultant vector. We have summation of f of x squared plus summation of f of y squared, and we will get their square root. The summation of f of x squared is equal to 329.9 newtons squared. And for summation of f of y, we have 75 newtons squared. Okay, so we will get their square values of 329 and 75 newtons. So we have 329.9 squared is equal to 108,834.01. You will have to write that full. Again, 108,834.01 Newton squared. Then we will get the square of the 75 newtons, and that is, using your calculator, type 75 square is equal to 5,625. Okay, write down on your equation 5,625. Okay, Newton squared. Then add the two values, okay, before getting their square root. So we have again R is equal to 108,834.01 plus 5,625. Okay, so that will give you square root of, you have again, and use calculator, 108,834.01 plus 5,625. That will give us an answer of 11,000 or 114459.01, I'd say. Okay, 114459.01. Okay, and then get the square root of that sum of the two vectors. We will get the square root of, type in your calculator, 114459.01 is equal to 338.32 newtons. And that is how far our magnitude of our resultant vector, 338.32 newtons. We round down into 2 decimal places. So that is our magnitude of the resultant vector. Now, to get the direction of the vector, we will use the tangent function. Tangent theta is equal to f of x over f of y. Okay, so that will be our formula. Again, our f of x is 329.90 and our f of y is 75 newtons. Okay, so we will divide 75 from 329, we will get, using our calculator, we have 329.9 divided by 75 is equal to 4.4. Okay, we will round off. So we have here 4.4. Okay, and then we have to transpose tangent to make it an inverse tangent, so that theta will be left on the left side of the equation. We have arctangent 4.4. Okay, so you have to type it on calculator using the shift button and then type tangent key or 4.4, which is our quotient earlier. We have 77.20 degrees, and that is the direction of our resultant vector. Okay, and that is our final answer or final calculation. We get the direction of the vector 77.2 degrees. Okay, let us have another example. We have here a car is headed east with a force of 10 newtons and then turns 25 degrees with a force of 15 newtons. How far is the car from its starting point, and what is the direction of its displacement? So based on problem number 2, we have this given. F of 1 or force number 1 is equal to 10 newtons is, or it is also equivalent to 0 degrees. Okay? And then F of 2 or force number 2 is equal to 15 newtons 25 degrees. Okay, so these are our component vectors. So using again the first formula, we will get their components. Okay, summation of f of x using the formulas f of 1x is equal to f of 1 cos theta. Okay, so to find the horizontal, again, we'll use cosine function. And then f of 2x is equal to f of 2 cos theta. Okay, substituting the given values, we have yung f of 1 natin is equal to 100 or 10, I should say, 10 newtons cos theta. Okay, so based on problem number 2, we have these given values. F of 1 or force number 1 is equal to 10 newtons or it is also equivalent to 0 degrees. And then we have F of 2. Okay, F of 2, again, we have 15 newtons, 25 degrees. Okay, so we will have to find again their component, horizontal and vertical, to find the magnitude and the direction of the vectors. So we have summation of f of x, or for the horizontal component, we have f of 1x is equal to f of 1 cos theta. So to find the horizontal, we use the cosine value. And then for f of 2x is equal to f of 2 cosine theta. Substitute the given values for f of 1 and for f of 2. So yung f of 1 natin is equal to 100 cos the theta is 0 degrees. And then for f of 2, we have 15 cos 25. So we'll have to type this on our calculator to easily solve. So we have 10 cos 0 will give us a value of 10. Okay. And then we have 15 cos 25 is equal to 13.59. So that is for our horizontal components. We have again 10 and then 13.59. Okay, so round off into two decimal values. Now we will get the summation of f of x. We have 10 plus 13.59. We will get 23.59, and that is our horizontal component or our summation of f of x. Okay. Now for the summation of f of y, or the vertical component of the component vectors, we have f of 1y is equal to f of 1 sine theta. And then for f of 2y, we have f of 1 sine theta. Again, we will substitute the given values. For f of 1, we have 10 sine 0 degrees. And for f of 2, we have 15 sine 25 degrees. Use again your calculator to solve for the vertical components. We have 10 sine 0 is equal to 0. And then we have 15, for the second one, 15 sine 25 is equal to 6.34. Okay, so write it here. We have 0 and 6.34. Add the two values to get the summation of f of y, or the vertical component. We will get 6.34 newtons. Okay, so that will be our vertical component, or the summation of f of y. Now, we have our new given. Summation of f of x is equal to 23. Now, for the summation of f of y, or the vertical component of the component vectors, we have f of 1y is equal to f of 1 sine theta. And then for f of 2y, we have f of 1 sine theta. Again, we will substitute the given values. For f of 1, we have 10 sine 0 degrees. And for f of 2, we have 15 sine 25 degrees. Use again your calculator to solve for the vertical components. We have 10 sine 0 is equal to 0. And then we have 15. Okay. For the second one, 15 sine 25 is equal to 6.34. Okay. So write it here. We have 0 and 6.34. Add the two values to get the summation of f of y, or the vertical component. We will get 6.34 newtons. Okay, so that will be our vertical component, or the summation of f of y. Now we have our new given values, which are summation of f of x, or the horizontal component. We have 23.59 newtons. And for the summation of f of y, or our vertical component, we have 6.34 newtons. We will use now the Pythagorean theorem to find the magnitude of the resultant vector. We have r is equal to summation of f of x squared plus summation of f of y squared. Substitute the given values. We have yung f of x ay 23.59 newtons, and then we will have to get the square value. And then plus summation of f of y is equal to 6.34 newtons squared. Okay, so get their square by typing them into their calculator. So we have square root of 23.59 muna. So using a calculator, we have 23.59 square is equal to 556.4881. So we have 556.4881. Remember to write it full because we are not getting the exact answer. Okay. Plus 6.34 square, we have, okay, so type it on your calculator. 6.34 square is equal to 40.1956. Okay, so we have here 40.1956. Add the two values, we will get, using your calculator again to make it easy for you, we have, okay, type in your calculator, 556, okay, again, 556.4881 plus the second one is, again, it is 40.1956. Okay, so we have 40.1956. So that is equal to, we have 596.6837. The square root of 596.6837. Now we will get the square root of that to get the magnitude of the resultant vector. Okay. So we have here the square again. R is equal to square root of 596.6837. Okay, 6837. Okay, so type that in your calculator with a radical sign to get the magnitude of the resultant vector. So we have the square root of, again, square root of 596.6837. Okay, 6837. We will get 24.43. Okay, so that is the magnitude of our resultant vector. Okay, just follow the step. You will not get the correct. You will always get the correct answer if you follow thoroughly the steps. That is our magnitude of our resultant vector. Okay, so the next thing that we will get is the direction of the resultant vector. So we have the tangent function. Tangent data is equal to f of x over f of y. Okay, so what is our f of x and f of y? Do you still remember? So our f of x is equal to 23.59, and then our f of y is equal to what? 6.34. Let's divide 23.59 to 6.34 and then transpose tangent to make it an inverse tangent. So we have 23.59 divided by 6.34, we will get 3.72. Okay, so write it on our board. We have 3.72. Okay, again, transpose the tangent function to the right side of the equation. We will get theta is equal to inverse tangent or arc tangent 3.72. Okay, so type that in our calculator. We will get the value of, we have again, shift, okay, tangent 3.72. So we will get the value 74.95, and that is the direction of our resultant vector, 74.95 degrees. That is the direction of our resultant vector. Now, to summarize what you have learned in this video, again, these are the 5 easy steps that you can use to add vectors using component methods. So we have first, determine the horizontal and vertical components of the given vectors. Second, add all the x vectors or the horizontal component vectors and label it as summation of f of x. And then, add all the y components and label them as summation of f of y. Fourth, use the Pythagorean theorem to find the magnitude of the vector. And lastly, use the tangent function to find the direction of the resultant vector. It's that easy. Just follow the step and you will get the correct answer. That's it for our lesson for today. If you want to learn more about this lesson, you can open the file on your flash drive with the file name Vector Component Addition Example. Now, you can also answer these values integration on your learning packet. We, as a Rowesian, has the core values of apostolicity. We are followers of Jesus Christ. Whenever Jesus goes, we should be like his apostles that are with him along the way. If we walk with him, he will never leave us and he will lead us to the right direction. But sometimes, there are things that deviates our path to the wrong way or some hinders us to proceed that lead us on leaving Jesus alone. How can you be a more productive apostle of Christ? Now that's it for our Unit 2, Kinematics. If you still have questions, you can call me during our specified consultation time. Now, let's check how you learned the lesson. Answer Unit 2, Activity 2 on the assessment sheets. And I am leaving you with this Bible verse. In all your ways, acknowledge Him, and He will make straight your paths. Proverbs 3:6. Thank you, and God bless. Happy learning, Rowesians.